Alright, let's do naming of some polyatomic bonds. And I think this is the easiest thing. It requires a lot more looking at your ion sheet, but once you identify the bond as having a polyatomic, there's really nothing that you're going to do except remember your IDEs and then look at your ion sheet to see what the name is of whatever the polyatomic you're using. So we'll do the same as we did before. We're going to do some examples, and we'll start off with names and we'll write the compounds. So we're going to look at something called zinc oxalate. Zinc oxalate. Now what you need to do is you need to go to your table and you need to look up zinc as well as oxalate. Zinc is right here. That's Zn2+. Zn2+. Then you have to look up oxalate. So you go down to this was the positive side, you want to be down to the negative side, and you want to find oxalate. This is in alphabetical order. So LMNO, there's oxalate right there, and oxalate ends up being, and I want you to put a bracket around these things, HC2O4 1-. That's a big one, but that's definitely a polyatomic ion. We crisscross these things, so the compound becomes zinc, the one you don't write, and it's going to be HC2O4 bracket 2. We're separating everything by a bracket, which is why every single time we do a polyatomic, you should throw a bracket around it. That's the first one. That's what zinc oxalate's compound looks like. Let's try another one. Let's go copper 2 phosphate. Okay, copper 2 phosphate. Well, I don't really have to look anything up. I know copper is Cu2+ because it's copper 2, but I don't know what phosphate is. So I go to my ion sheet. Phosphate's right here. That's PO4 3-. Open a bracket. PO4 3-. I crisscross them and I'm left with Cu3 bracket PO4 2. So that's copper 2 phosphate right there. Let's try one more. Let's go with ammonium sulfite. It's not IDE, it's ITE, so this is a polyatomic and so is that. You're allowed to do that. You just look them up. Left hand side is going to be positive. That's ammonium. That's NH4+. And sulfite, this is IDE. You don't want that. You want not this one. That's ATE. You want ITE right there. SO3 2-. So aluminum was NH4 1+. And sulfite is SO3 2-. Crisscross those, and you're going to end up with NH4 2, and SO3 has a 1, so that's right there. That's ammonium sulfite. That's polyatomic. See, there's really nothing to it. You just have to look up what they are. The name to the compound is just knowing what the charge is, or what the your combining capacities and crisscrossing them. A little bit different when we go the other way. When we actually give you the compound FeOH3. Well, first thing you want to do is remember that iron has the possibility of having some stock numbers. And if I reverse engineer this thing, that's going to end up being Fe3+. So I just want to check to see if that's actually on here. There's iron. It's iron 3. So I'm going to actually call this thing iron 3, and then I have to look up what OH is. So you actually have to take your ion sheet out, look down the sides until you find OH. There it is, hydroxide. Iron 3 hydroxide. There. So all you're doing is writing the name of the polyatomic down. Okay, let's try another one. Let's go with Al, and we'll take OH again. OH3. Push pause, see if you can name that.
Okay, hopefully you tried it. I'm just going to double check to make sure aluminum 3 isn't a stock number. And there's aluminum 3 plus, but it's not highlighted, so it's not. So that's going to be aluminum. And we already looked this up earlier, it's hydroxide, so it's aluminum hydroxide. Let's try one more. Here's a crazy one for you. Hg3, open a bracket, PO4, 2. Give it a try. Push pause. Okay, let's see how you did. Remember we talked about this in class. For Hg, there's 2 of them here. There is mercury 2 and mercury 1, but mercury 1 is Hg2 2 plus. We're not even going to use this year, so that's why we never even look at it. It's mercury 2. So Hg2 plus is actually mercury 2. So this one, because there's a 2 here, it goes over to mercury and 3 goes to the PO4. So this is going to be mercury 2. So that's mercury 2. And then we have to look up PO4. PO4 is phosphate. So mercury 2, phosphate. Okay? Now, I just want to point out one thing, a little bit of a trick for you here. Not all the stock numbers are actually listed. So if I would have given you this exact same question, I'm going to write it even below. Hg3. And if I told you my polyatomic ion was PO4, and I told you the charge was something other than what is on the back sheet here. Let's say I said it was a 4. You go to the back, you go, well, I'm looking for Hg4. I'm looking for mercury 4. Let's see if it's here. Well, mercury's on here. There is a stock number for mercury. I don't have mercury 4 down here. That doesn't necessarily mean it doesn't exist. It doesn't, I'm sure. There's no such thing. But if there was, you would go, well, this is mercury. I know it's a stock number, so I'm going to call it mercury 4 phosphate. You can just create that. There you go. That was naming polyatomic ions. Hope that helps.